Hello everyone, welcome for this lecture. Today we are going to continue with a solution on signals. We'll solve one more numerical on addition, that is a basic operation on signals. Okay, so we'll take this signal. Okay, let's say x1 is u of t and x2 is triangle signal. Okay, let's solve this. Just we are going to take a addition of this. It is a first signal x1 and x2. We are supposed to get a y of t, which is addition of these two, x1 plus x2 of t. Okay, let's calculate this. It gives us, since you can observe these two, see this is your x1 and x2. You be careful about this. It is your u of t. Okay, this is u of t, means the signal is unit step, right? It starts from 0 and magnitude is 1 with up to infinity, okay, till time t. Okay, and then this signal you supposed to add with this. Okay, so this signal is a triangular signal. Okay, single signal, right? It is started from 0 and reached to maximum of 1 and then it is ended at 2. Okay, which is fixed defined signal. Okay, which is a continuous signal. So these two we need to add. Let's see how we can add it. Just observe these two signals and then say at 0. Okay, at 0 x1 signal is how much? What is the x1 signal and what is the x2 signal? That we have to check. Let's see, at 0 x1 signal, its magnitude is how much? It is 1. Okay, 1. What about x2 signal at 0? Magnitude is 0, right? So 0. What we have to do operation is x1 plus x2. So that you get as a y of t. So x1 is 1, x2 is 0 at 0. Okay, at 0. Its value will be 1. Okay. And next we will take at 0.5. Okay, let's take at 0.5. It is it is, we can observe here, right? It is at 0.5. Its magnitude is how much? We can take it as a 0.5 and here we can take it as 1.5 and so on. It is continuous, right? So at 0.5 first signal magnitude is how much? 1. What about second signal magnitude at 1 second? Okay, at 1 second, what is the magnitude of this signal? It is 1. So and then sorry, at 0.5, right? Sorry, at 0.5. Okay, at 0.5 what is the magnitude of this? If at 1 it is a 1, then it's at 0.5 it will be 0.5. Okay, then u of t magnitude will remains the same if you observe, right? So second signal is 0.5. So what about this? Add these two, it will be 1.5. Okay, next we'll take at 1. Okay, at 1 also u of t's magnitude is 1. And what about second signal is 1. So that you have to take 1 plus 1 is 2. Magnitude is 2 now. And then change at 1.5 seconds. Okay, t is at 1.5 seconds. Its u of t value is remains the same, 1. And what about here? It is 1.5. Then its magnitude is 0.5. So take this, it is 1.5. And next at 2, first signal remains the same. What about second signal is 2. Sorry, what about 2? It is 0 magnitude. So it is 0. At 2, 1 plus 0 is 1 magnitude. Okay, and the next you continue with 3. 3. At 3, its magnitude, first signal magnitude is 1. What about second signal? There is no signal. You can take it as a 0. When there is no signal, I have to take it as 1. Sorry, 0. Then what will happen? 1 plus 0 will be 1. So when you take 4, 5, 6, so 7, so and so on, only first signal will be present. Okay, that is 1. Only first signal will be present, but second signal will not be present. It is 0. So addition of these two will be 1, 1, 1, 1, 1. So therefore we can draw this entire signal. Okay, so this is your y of t signal, which is x1 plus x2 signal. Let's add this. let's take at 0, 1 second, 2 second, 3 seconds, 4 seconds, 5 seconds, and so on. You can mention in between that also. Between 0 to 1 there is a 0.5 and so on. Okay, we'll mark it at 0. Okay, at 0, what is y of t? This addition, okay, added last column we have to consider. Okay, what about at 0? Its value is 1. Okay, we'll take its value is 1. Okay, and then at 2 is how much? At 2 is how much? Sorry, it's okay, right? At 0 it is 1. Okay, at 0 it is 1, right? At 0.5 it is 1.5. At 1 it is, at 0.5 it is 1.5. Okay, at 1 it is 2, at 1 it is 2, and at 1.5 it is 1.5. Okay, again it has decreased, and then at 2 it is 1 again, right? At 3 again 1. Okay, at 4 it is again 1, 5 it is again 1, and so on. It remains 1 only further. Okay, let's draw this. Let's draw this. You will get a signal like this. Okay, this is your y of t, which gives you addition of x1 plus x2 of t. Okay, so we'll move to the another one. Okay, so you just observe. So what signal you have got? Addition of those two. Okay, so you may get this, right? It remains the same till t time. Okay, now we'll start with the multiplication. Another one basic operation, that is multiplication. Okay, so now y of t will be equal to, here if you have a two signals, so you can multiply those two. Okay, so x1 of t into x2 of t. Okay, now you just observe, x1 of t is, you take one signal, and x2 of t is another signal. Let's multiply what we get. Okay, so see, now what we have done is x1 of t is also u of t, and x2 of t is also u of t. Okay, observe, u of t signal, you know, this is your unit step signal, and this is your unit another unit step signal. Okay, so when you observe these two, right, those two are same. All right. Okay, so u of t is unit step signal with a magnitude of 1, right, up to time t time seconds. Okay, so then we have a same signal which is of u of t. So it is nothing but, if you would like to observe, so if you have observed carefully, y of t is nothing but 1 into 1, which has to be 1. That we need to prove. Okay, so u of t into u of t, it remains u of t only. Okay, that we have to observe. Let's take, this is x1 of t, and this is your x2 of t. Let's start doing it. At, it is a time column, and it is x1 column, and it is x2 column, and it is y of t column. Okay, now at 0 seconds, both the signals are how much? X1 is 1 and x2 is also 1. 1 into 1 is 1. At 0.5, 1 into 1 is 1. At 1, 1 into 1 is 1, and so on. Okay, so these values you can put it here. So which is, at 0 it is 1, at 0.5 it is 1, at 1 it is 1, at 1.3 is also 1, and okay, and 4, 5, 6, whatever you can take the values, it remains same. Means 1 into 1 is, how 1 into 1 is 1. Similarly, u of t into u of t is also gives us u of t. Okay, so let's take another example on this. Okay, it is remains the same as we discussed. So now let's take a different one, bit different one. Okay, so just observe, in this equation x1 of t is this signal, and x2 of t is this particular signal. Observe carefully those two signals. Okay, both are triangular signals, okay, or you can say it is a ramp signal, which I hope in Laplace transformations electrical circuit analysis would have done this, would have got this signal by ramp signals. Okay, that we can deal later. Okay, now you can just observe. Okay, so these two signals we need to find out the multiplication of this. Let's take, since we have observed these two signals, let's start solving the numerical. Okay, so similarly you follow this rule till you get a practice. Okay, once you practiced, directly you can multiply and keep. There is no need of writing also. Okay, yes, let's start doing, because since we are in a basic concepts, we'll start doing it manually, and then directly we can do it further classes, in further classes. Okay, at -1, because this signal is started at -1, and even this signal is also started at -1. You just observe the graph. This graph should be known for all. Positive t, it is a negative t, x-axis. Okay, this is a x-axis, y-axis, this is a positive part and it is a negative part. Okay, just observe this signal which has a positive dimension. Okay, magnitude is positive, and whereas this signal negative magnitude we have. Okay, so let's take at -1. At -1, what is the first signal value? 0. What about the second signal value? It is also 0. When you multiply this, okay, it will be at 0. And next at -0.5. Okay, at -0.5, what's the value of first signal? First signal value is how much? It is 0.5 positive. Okay, plus 0.5, so it is plus 0.5. What about the second signal at -0.5? It is at negative -0.5, so it is -0.5. So 0.5 into -0.5 gives us -0.25. Okay, and then next you observe at 0. At 0, okay, first signal value is +1, second signal is at -1. So 1 into -1 is -1. Okay, so you can take at a positive side now. When you are going to consider at positive 0.5, okay, 0.5, so its value is plus 0.5. Okay, magnitude is 0.5. Second signal is what? This is -0.5. Okay, it is same. You can observe here at plus 0.5 you will have 0.5 into -0.5, which gives us -0.25. Okay, and then at 1 we'll observe again. At 1, first signal value is 0 and the second signal value is also 0. So therefore at 1 you can observe 0, 0. Okay, now we have to take these values and mark here. Okay, let's mark on this. At -1 it is 0. Okay, and at -0.5 it is -0.25. Okay, see, observe, this is your -0.25, and then next at 0 it is 1. Okay, and at plus 0.5 it is again a -0.25. Okay, and then at 1 it is 0. So when you draw this, it will be like this. Okay, you can observe here what we have done. Okay, at -1 it is 0, at -0.5 it is -0.25, at 0 it is 1, at plus 0.5 it is at -0.25, and then at 1 it is equal to 0. Okay, this is how the basic operation on multiplication can be done. Okay, we will move to a next topic, that is time shifting and time scaling. Now this is another one which operation can be done performed on the independent variables. Okay, independent variables. Remember, when you say independent variables, okay, it is related to x-axis. Okay, first one on dependent variable, what we have done is totally on the y-axis magnitude variation was there, that is with respect to y-axis operation, it was corresponding to y-axis. Now entirely is going to corresponding to your x-axis. Okay, let's see how can be done this. There are two again, time scaling can be done and time shifting can be done. Let's take a first one, that is a time scaling. When you are taking a time scaling, if you say x of t is your signal, then time scaling can be defined as y of t is a time scaled signal which is operated as x of at. Means you are going to multiply, means you are going to operate with respect to a time. Okay, I hope you would have got the difference between time scaling of this and scaling, amplitude scaling. Okay, amplitude scaling was with respect to y-axis, that is if you have a u of t is a signal or x of t is a signal, that has to be multiplied with some magnitude. Okay, say suppose phi x of t. Okay, there was t was independent there. Okay, so it was not varying with respect to t, that is x-axis. Now this is time scaling, means it will be x of at, means with respect to this you are varying time, we are varying, that we will see. Okay, first one is time scaling. In that we have done time scaling is, if x of t is a signal, then y of t will be equal to x of at. Okay, where a is the constant. Okay, let's find out an example for this. Okay, find x of 3t. Okay, if x of t is this signal, is nothing but your u of t, right? Okay, x of t is nothing but your u of t. Now we need to find out x of 3t. But when you are finding out this one, what we have to do is, this is your x of t. Okay, sorry, what you have to do is, this signal is your, okay, so x of t. So for this x of t, what we have to do is, so let's take what they have asked, let's take what they have asked to calculate 3t. Let's take 3t is equal to 1. Okay, so because this is a multiplication, with respect to time it is a multiplication, so what we have to do is 3t equal to 1 we have to take. Then what about t? T should be equal to 1 by 3. Okay, t equal to 1 by 3. 1 is there, 3 you send this side, it is 1 by 3. Now what we have to do is, in the x of t, okay, in the x of t signal, t has to be changed to 1 by 3. Okay, in the signal x of t, you have to change t to 1 by 3. Okay, in the original signal. So what you have to do is, observe, this is your x of t. What is this? Okay, this is not, this is your x of t. Okay, this signal is your x of t. Now it is unit step signal. What you have to do is, in this signal you have to multiply wherever you have t. This is t, it is 1 second is also time, 2 is also time, 3 is also time. So at each time what you have to do is multiply that with respect with 1 by 3. So 1 second is there into 1 by 3, 2 is there, 2 into 1 by 3, 3 is there, 3 into 1 by 3, and 4 is there, 4 into 1 by 3, and so on. 5 is there, 5 into 1 by 3, and so on up to time. Okay, up to time t, right? Once you have done, just simplify this. 1 into 1 by 3 is nothing but 1 by 3, it is 2 by 3, it is 1. Okay, 3 get cancelled, it is 1. Okay, it is 1 by 3, it is 2 by 3, it is 1, and it is 4 by 3, and 5 by 3, and so on. So your x of t signal will be, okay, your x of t, sorry, x of 3t signal will be, x of 3t signal will be what? It is, magnitude remains the same. Okay, magnitude remains the same, it is only corresponding to x-axis, that is going to vary. Okay, so just observe, time instead of it was 1, now it is at 1 by 3, it is at 2 by 3 second, it is at 3 second, it is at 4 by 3 second, it is 5 by 3 second, and so on seconds. Okay, right? So now we'll do, we'll take another example. Let's solve this. Find x of t by 3 for the same signal x of t. X of t was our unit step signal. Okay, this was our signal. So now we'll take, what you have to do for that, whatever they have asked, that is x of whatever it may be, get that. Okay, just take. it is t by 3. Okay, t by 3, so equate it to 1. Then what about t? T will be equal to 3 seconds. Now what we have to do? Change the t to 3. Okay, whatever t is there, just multiply with 3. Okay, now see, this is x of t signal. Okay, this is your x of t signal, right? So now what we have done is, so this is your u of t. It is started from 0, magnitude is 1. Remember, magnitude remains the same, only scaling which is going to vary, 1 2 3 4 5 seconds and so on. Now we need to find out t is equal to 3 by now we need to calculate t by 3, that is x of t by 3. So what we have to do is, we have sent that t by 3 is equal to 1 and t will be equal to 3. So now we are going to change the time to 3t. Okay, so let's take t by 3 can be is nothing but at 1 second, whatever we had at 1 second, it has to be multiplied with 3. 2 you had, multiply with 3. 3 you have, multiply with 3. So 4 you have, 4 into 3 and so on. Okay, then simplify this signal, you get, observe, magnitude remains same at 1. This is your x of t by 3 signal, which is 3, at 4, at 9 and at 12 and so on. Okay, what you can say from this is, suppose if you are multiplying the scale, okay, multiplying this time at, okay, if it is like 3t, 5t, 6t and so on, if you are multiplying with the higher values of t, then your signal is going to contrast. Okay, your signal is going to contrast. Suppose if you are dividing your signal, okay, if you are dividing your signal, time I am speaking, okay, dividing signal means not with respect to divided by this, okay, I am speaking with respect to a time signal, time of that operation with respect to time. Okay, it is going to corresponding to your time x axis. Okay, if you are dividing that, then your signal is going to expand. Okay, now you can observe, this was at 1, now it is at 3. Okay, it is going to expansion. Okay, so now another one we have is the time shifting. Okay, that is a time scaling which you have multiplied with the time. Now your time shifting means suppose if you have u, let's say signal u of t. Okay, I'll take here, if you have a u of t signal, which is this signal, okay, 0 and it is 1 up to time t. Okay, so suppose if you ask us to shift, that is u of minus t. Okay, u of minus t, this is what it is, a u of t. This what we need to calculate is minus t, we have to calculate. What is a minus t? For that what we have to do is just observe this graph, which indicates this part is plus t, this part is minus t, and this part whatever you are seeing on the y-axis of positive magnitude, this is a negative magnitude. Okay, suppose u of t, what you said, it is a u of t. So okay, u of t means always it moves in this positive direction, t. Okay, now when they ask us to calculate minus t, then this signal should be mirror image of u of t. Okay, I hope you have got this. I'll repeat again. U of t we know that is a positive time, okay, which signal gives us a positive signals at a t seconds. Suppose if they ask us to find out minus t, then this signal has to be at a minus side. Okay, that has to be at minus side, same magnitude. Okay, one magnitude only, but with the opposite direction. Okay, u of minus t, right? Let's take this. It is your u of t. When they ask us to find out u of minus t, then this is a t and it is a minus t. Okay, so then signal, instead of going in this direction, it is goes in this direction, that is in this direction. Okay, u of t and u of minus t. Remember, this is nothing but your mirror image. Okay, and next let's calculate. We'll speak about this later. I'll have bit space over here. Okay, now we'll calculate u of t minus 1. Okay, u of t we know, right? U of t we know, that is this signal starts from this with the magnitude 1. Okay, right? This is your u of t. We require u of t minus 1. That time what we have to do is, let's get what is there in this. You have to take it. T minus 1 is equal to, don't put it to equal to 1. There is addition and subtraction. Algebraic sum is there. So what we have to do is equate it to 0. Okay, then t will be equal to 1. Alright, send this minus 1 back to equal side. Then t equal to 1 seconds. So whatever signal you have originally, that signal has to starts from 1 second. Okay, so what we have to do is, this was your initial signal. So now we have to shift, means the signal was starting from 0. Okay, so at 0 this was 1. Now that signal has to start at 1, means take a signal, it has to starts from 1. Okay, t equal to 1. So this is signal at 1 it has to start. Earlier it should be 0. Okay, at 0 also it should be 0. Only at 1 it has to start with the same magnitude. Magnitude will not change. Okay, this is u of t. Okay, which was starting at 0 signal. Okay, which was starting at 0 signal, and at 0 seconds. Okay, your signal was giving you information at 0 signals, but at this signal, that is u of t minus 1 signal will be, that is t minus 1 equal to 0, t equal to 1, means your signal has to, whatever it may be, the original signal has to be start from 1 seconds. So now this was starting at 0, now it will start at 1. Initially all signals will be zeros and it starts at 1. Okay, this is a shifting. Okay, this you can say it is a delayed signal. T minus 1 is a delayed signal. Let's take u of t plus 1 then. Okay, u of a t plus 1 signal. So what we have to do is allow t plus 1 equal to 0, then t equal to minus 1. Though u of t is how much? U of t plus 1. It means u of t was how much? This was. At 0 this signal was 1 and up to t it was there. Right? What about u of t plus 1? Means t has to be start from minus 1. It is the advanced signal. Okay, the signal has to start from minus 1. So what we have to do is, for that is, observe, this is 0 and your signal should not start as 0. Its signal should not start at 1. It has to start from minus 1. Where is your minus 1? Here it is your minus 1. Your signal has to start from this. Okay, I'll draw again. U of t plus 1 is t plus 1 equal to 0 and t is equal to minus 1. Okay, t is equal to minus 1, and then our signal t u of t was like this, and then u of t plus 1 signal, this is your u of t. Okay, this is your u of t signal. U of t plus 1 signal will be starts from minus 1. Okay, magnitude remains the same, 1. This is your u of t plus 1. Okay, let's do another one, that is u of t plus 3. Okay, what can be this might be, it is t plus 3. Let's take 3 plus t plus 3 equal to 0. T is equal to minus 3. Remember, this is u of, means u of t plus 3 means original signal was u of t. You should know what is u of t. U of t means a signal starts from 0. Signal will be present from 0. Okay, and greater than 0, that we have already defined. Now we need to draw u of t plus 3. The meaning of this one is this signal starts from minus 3. Then what we have to do is take it is a minus 1, minus 2, minus 3. Then initialize 0. Signal starts from minus 3. Signal magnitude remains same. That's what this time scaling and time shifting, these two operations are corresponding to x-axis. Okay, and then let's do another one. Minus u of t is how much? What is this? U of t we know, that is this is your u of t. Minus u of t, this is plus 1. Okay, right, this is minus u of t means magnitude is minus. Okay, it was u of t which gives us u of t means this was u of t means positive magnitude. Okay, 1 u of t, positive plus 1. Now what we have to do is minus u of t means u of t remains the same. Okay, but thing is negative magnitude. Magnitude where it comes, that has to be downward direction. Okay, so minus 1 is here. So minus u of t will be this one. Okay, this is your t. Time is at a positive side, but magnitude is negative. Okay, this is your minus u of t. Okay, and then next you can do similarly like this. Minus u of t minus 3 will do. Okay, what you have to do is, there are two things. One is its signal magnitude is negative, and another one is it has shifted with minus 3, means t minus 3 is there. For that what we have to do is, first let's take this one. Okay, for here you see this one, you take t minus 3 is equal to 0. So t is equal to how much? Plus 3, means your signal has to start from plus 3. Okay, and then what about its signal's magnitude is negative. Okay, u of t you know, that is this direction. First you get minus u of t of that. Okay, let's get minus u of t. This signal we have to get. So for that t is equal to minus 3. Okay, so now we'll get the signal. Okay, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, and then minus u of t means negative. Minus 1 is the magnitude. So it should be starting from this. Okay, it is, then it should be like this. Okay, it remains the same. Okay, this is your minus u of t plus 3. I hope you have got this. We'll solve some more numericals on this. Any questions you can put on the group. Okay, we'll stop doing this. If you want, we'll solve the more numericals on this. Okay, thank you.